Good day, everyone. I'm Bacalso Christian James, and we are the Group 1. And my members are Abadiano, Abarques, Alingato, Anhao, Bacalso Renz, and Bacalso Kijay, which is me, and Burok, Bustamante, and Kabanday. We are here today to describe the importance of ship's turning circle in ship handling and compare the turning circle in ballast condition to the turning circle in loaded condition. And
Good day everyone, I am the Cadet Nathaniel Anao. For today I'm going to discuss about importance of ships turning circle in ship handling. So, the circle is the path of ship pivot point as it execute a 360 degrees turn in shallow water. The rate of turn is likely to be decreased. So the vessel will have a larger turning circle.
Good day, I'm the Cadet Alingato. So I will start to report. Once trial and new ship are complete, operators will need to know how the vessel can expect to perform in variety of sea conditions. The ship handler, for instance, should be aware of how long it will take for a vessel to become stopped in the water from a full ahead position, or how far the vessel will advance in a turn. Turning circles and stopping distance speed trials provide such essential information to those that control today's ship. That's all. Thank you.
So hi everyone, my name is Decadet John Lawrence Bacalso. So this is my slide. So note, merchant ships usually turn circles having a diameter of about 3 to 4 times the length between perpendicular or LBP. The larger the rudder, the smaller will be turning circle diameter, TCD maneuver. The ship will experience transfer advance, drift angle, and angle of the heel. So let's look at the graph.
So hello guys, I am Abadiano Nestor Jr. And there are 7 factors affecting turning circles of a ship. First is the draft and trim. Second is the distribution and stowage of cargo. Third is even keel and listed. And the fourth one is the rudder angle. Fifth is the available depth of water. The sixth is drift angle and influencing forces. And the last one is the structural designs of length.
So good day sir, I am Cadet Abarques, and here are some examples of the turning circle in ballast condition to the turning circle in loaded condition. So this first picture is shown, first example is turning circle is at normal full loaded condition with maximum rudder angle full ahead RPM. So full sea speed 104 RPM, and the transfer diameter is 0.41.1 nautical miles, and the transfer diameter on the starboard side is a 0.54 nautical miles, and the advance is 0.388 nautical miles, and on the starboard 0.373 nautical miles. So in the port side it has 25.52 knots, and the starboard side is 25.52 knots also. So in this second example, it is a turning circle normal ballast condition with maximum rudder angle full ahead RPM, full sea speed 104 RPM, and the transfer diameter is 0.568 nautical miles. Starboard side is practical diameter 0.581 nautical miles. So the next example is turning circle loaded condition with maximum rudder half half angle RPM. So in the port side, the transfer diameter is 0.424 nautical miles, and on the starboard side, the transfer diameter is 0.428 nautical miles. And port side knots is at 12.76 knots, and starboard side is 12.76 knots. And lastly, turning circle at normal ballast condition with maximum rudder angle half ahead RPM. So the transfer diameter is 0.582 nautical miles, and the tactical diameter is 0.52 nautical miles. Port side is at 13.05 knots, and the starboard side is 13.05 knots. So that's.
Hi, good day everyone. I am Det Cadet Kabanday, and today we're gonna talk about diameters, transfer, and further reading. First, we're gonna talk about diameters. The greatest diameter described by the vessel from starting the turn to completing the turn, ship head through 180 degree is the tactical diameter. The internal diameter of the turning circle where no allowance has been made for the decreasing curvature as experienced with the tactical diameter is the final diameter. Transfer. This is defined by the distance which the vessel will move perpendicular to the fore and aft line at the commencement of the turn. The total transverse movement lasts from the start of the turn to its completion, the defining limits being known as the transfer of the vessel when turning. Further reading. The IMO released MSC.13776 or Standards for Ship Maneuverability identified the following characteristics. First, inherent dynamic stability. A ship is dynamically stable on a straight course if it, after small disturbance, soon will settle a new straight path without any corrective rudder action. The resultant deviation from the original heading will depend on the degree of inherent stability and disturbance magnitude and duration. Second, course keeping ability. The course keeping quality is a measure of steered ship's ability to maintain a straight path in a predetermined course direction without excessive accelerations or off rudder or heading. In most cases, reasonable course control is still possible where there exists an inherent dynamic instability of limited magnitude. Third, initial turning or course changing ability. The initial turning ability is defined by the change of heading response to a moderate helm. In terms of heading division per unit sailed, or in terms of distance covered before realizing a particular heading division, such as the time to execute second demonstrated when entering the zigzag maneuver. Fourth, yaw checking ability. The ship's yaw checking ability is a measure of the response to counter rudder applied in a specific state of turning, such as the heading overshoot reach before the counter rudder has cancelled the yawing tendency in standard zigzag maneuver. Fifth, turning ability. Turning ability is a measure of the ability to turn the ship using hard over the rudder. The result is a minimum advance at 90-degree change of heading and tactical diameter defined by transfer at 180-degree change of heading. Lastly, the stopping ability. Stopping ability is the measure by the track reach and time to dead in water, realized in a stop engine full astern maneuver performed after a steady approach at full test speed. That will be all for today, and thank you for your attention and listening. See you next week.
That's all. I sincerely appreciate your attention today. And that brings us to the end. I'd like to thank you for your time and attention today. Thank you so much for your interest and attention. Have a good day. Goodbye.